Right then, now we need to talk about data types. So, as you know, data is just information, right? So, for example, your name is data, or your age is data. But we also have different types of data. What do I mean by that? Well, your name is text, and your age is a whole number, right? Well, that's what I mean by data types. And in this video, I'll talk about the different types of data you will need to know about when programming, because they all have very specific names that you need to know. Let's play the intro. Okay, so this is a sort of theory episode, but we will write some code because I've mixed this episode in with operators as well. There are lots of different types of data that you need to know about. The very first is a string, and we actually made quite a few of them already. A string is just text. Let's open up the project we had open before. So to do that, just hop into Visual Studio, and over in the recent section, you should have an option to load your project again. Now look at all of these console.write lines. You'll notice that within the brackets, we have a starting quote and an ending quote. This marks a string. So whenever we have these quotes, it means that we're creating a string. So we create this string, and then we put that string into the brackets of console.write line. And that is what these quotes are all about. Okay, so that's the first data type. It's text, and here's an example there. Next, we have an integer. This is a whole number, just like your age. Let's look at how we write that out. So, instead of putting a string in here, we will put an integer. And to do that, we just write a number. No quotes. If we wrote it like this, then that would be a string. It would be the text for that number. But that's not what we want. We want an integer. We want the actual number itself. We don't want the symbols that make up the number, so we don't write it with quotes. Now, in C#, integers are 32-bit, so they are 4 bytes long. So that means that they do have a limit, although it is extremely high. The next data type is a float. This is a decimal number. Now, C# does technically have 3 different types of decimal numbers. It has a float, double, and decimal, but those are very specific to C# and generally don't apply to other languages, so let's just call it float. Making a float is the same as making an integer, except we put a small f after it, like this. And that f stands for float, of course. The next one we have is a byte, which, unlike an integer, is literally 1 byte, and it can only do 0 to 255. And the final one we will talk about is a boolean. This has a very odd name compared to the rest, but it's really very simple. It's either true or false. That's it. To make a boolean, just type either true or false. Remember though, don't put it in quotes, because if we do put it in quotes, then it's literally making a string with the letters T, R, U, and E in it, which is not what we want. Remember, anything with quotes around it is just text. Now, WriteLine is smart. It automatically turns all of these data types into a string for us. So that way, if I do this without the quotes, it will work fine, even though this isn't text. However, most other parts of C# are not quite this smart. Let's look at an instruction that isn't so smart. It's called int.parse. I just picked that completely randomly. Now, let's not worry about what this instruction actually does. In fact, it won't really do anything because we aren't using it right. But look at this. If I put a string in the brackets, then that's fine. No compiler errors there. That's what it wants. It wants a string. But if I try and put an integer into the brackets, then it's not going to be so happy. That's because an integer is not the same as a string. If you look at the error, it literally says that it cannot convert from int to string. In order to use an integer here, I would have to put it through an instruction that turns the integer into a string. Let's talk about why then. Why do these data types just not work? Why do we have to convert them? Well, in order to answer that, we have to look at it at a binary level. Now, as you know, binary is either ones or zeros and we group it together into bytes. Sometimes, if a number is bigger than 255, we might group it together into lots of bytes. Now, let's look at how numbers are actually stored in those bytes. So, this is our byte right now. What we're going to do is add some markings just above it that will help us to understand what happens when we turn one of these bits on. Let's go all the way to the right bit and put a little 1 above it. What this means is, when this bit right here comes on, it's going to add 1 to the number this byte represents. Okay, let's keep going. The next bit will have a 2 above it. If this bit is 1, then that means we'll add 2 to the number this byte represents. Now already, with these 2 bits, we can actually make 0 to 3. How? Well, if I have 0, 0, then that's 0, right? If I have 0, 1, then that's 1. Because if we look at our markings here, when this bit is turned on, we add 1 to the number. Okay, so what if we wanted to make 2? Well, if we look at our markings again, we can see that above the bit on the left, we have a 2. So that's telling us that if we turn this bit on like this, and turn the other one off, then we'll have 2. Okay, but now what about 3? Well, it's 1, 1. Why? Well, look at our markings. We have 2, and we have 1. And both of them are turned on at the same time, so they add together to make 3. Let's expand this out one more. The next one has a marking of 4. So if we turn on this bit, then we add 4 to the number. Now, we can make 0 to 7. Let's briefly look at this. If I have 0, 0, 0, then that's 0. If I have 0, 0, 1, then that's 1, because we know that this bit will add 1. If we have 0, 1, 0, then that's 2, because we know that this bit will add 2. If we have 0, 1, 1, then that's 3, because we have both 2 and 1 turned on at the same time. So that's 3. Then we have 1, 0, 0, which is 4, because this bit is worth 4. Then we have 1, 0, 1, which is 5, because we have 4 and 1, which together makes 5, and so on. I think you get the idea. Now, you may have noticed a pattern with these markings. They double each time. We have 1, then double that, we get 2, and double that, we get 4. So that means the next bit is 8, then 16, 32, 64, 128, and we made a byte. That is how binary works. So, let's work out 1, 0, 1, 0, 1, 0, 1, 0. That's 128, and 32, and 8, and 2. So, if we add all of those up, then we get the answer 170. So that's how binary works. And if we have more bytes joined together, like we do with a 32-bit integer, then these markings will just continue to double and get bigger and bigger. Now, that's all great, but I've only talked about numbers. How is text done? I mean, what I just showed you is binary, and that is how it works. So how do we store text? Well, it's really very simple. We give each different symbol a number. So, for example, a capital A is 65, and a capital B is 66, and so on. Now, that's all well and good, but how do we know what number is what character? Well, that's where character sets come in. A character set basically says what binary numbers are what character. There are two really common ones, ASCII and Unicode. In ASCII, one character is 1 byte, and sometimes even just 7 bits. This used to be fine, but this only means that there can be 255 or even 127 characters. So when you include capitals, non-capitals and everything else, there isn't really much room to add any more characters. Whereas Unicode is a standard that tries to support every language in the world, including languages such as Chinese, which have thousands of characters. Unicode comes in lots of different forms, but generally each character is 2 to 4 bytes in Unicode, which gives it much more room for more types of characters. And now we get to the reason why strings and integers are two very different things. Let's say we have an ASCII string with the text 34 in it, and we have an integer that is 34. Those two would look very different. The ASCII string would be 2 bytes, because it has 2 characters in it, and it would look like this. Then, because of the ASCII character set, it would know that this number is a 3, and that this number is a 4. This is very different from what 34 actually looks like in binary, which is this. So, hopefully it makes sense that we need some kind of translation from this type of data to this type of data, and that's what a converter would do. And WriteLine actually does this conversion automatically in the background. So, now that we understand different data types, let's look at what operators are. Now, operators are things such as adding, subtracting, multiplying, dividing, and various others. But the thing is that the operator will do different things to different types. So, if I write 34 plus 10, then I'll get 44, right? Because I'm adding 2 integers together. But if I write quotes 34, quotes, plus quotes 10, quotes, then we're adding 2 strings together. And in C#, when we add 2 strings together, it joins them together. So, instead of getting 44, we'll get 3410, because it joined these 2 strings together. Right, let's run this. So, the first one, which was adding 2 integers, did what we expected, right? It gave us 44. Let's hit enter to run the next one. And now, we've got 3410, as I said we would get. So yeah, that's pretty much what we expected. Adding 2 integers will of course work, but adding 2 strings just joins them together. So if we had 2 strings of numbers, and we wanted to actually add them together, we would have to convert them to integers first. Okay, now let's talk about why brackets are important. Let's say I want to write the answer is, colon, and join that on with what 44 plus 50 is. So, like this. We say the answer is, and then we calculate 44 plus 50, and that's joined on, right? So, we're expecting the answer is 94 to be put on the screen. But no, that's not going to happen. Let's run it and see what we get. We got the answer is 4450. Why? Well, let's think about how the compiler sees this, and how it will compile this. It sees the string, the answer is. Okay, fine. Then it sees a plus, which means join onto the string. So it thinks, okay, right, they want to join something onto it. Then it sees 44. Now, yes, 44 is an integer, but the compiler is smart and automatically puts a converter around that, so we're fine. But now, because we've got this join thing here, and we've got 44, it joins that 44 onto the string. And now we have the string, the answer is 44. Yeah, I think you can see the problem. Then it sees a plus 50, and it thinks, you want to join something else on as well. So it compiles code that joins 50 onto the string. And now we have the answer is 4450. So, how can we fix this? Well, it's actually extremely simple. As you might know from just general maths knowledge, if you put something in brackets, you're telling it to work that out first. So if we put just plain brackets around the 44 plus 50, then it's a different story. Let's run it first to make sure it works, which it does, and let's look at how the compiler sees this. So what happens now is the compiler sees these brackets, and it knows that this means that this needs to be done first, before the rest of the operators are ran. So, it works out what 44 plus 50 is first, and then it takes whatever the answer to that was, which was 94, and joins that onto the string the answer is. And that is why it works, and that is how operators behave around strings and integers. And that is the end of the video. In the next video, we're going to start putting our own data into the RAM, and these data types are going to be really important in order to describe how the data will be stored in RAM. So that's the end of this video. We covered these 5 data types right here, and we covered how operators behave with brackets. Be sure to set the boolean that says whether you're subscribed to this channel to true, and be sure to also increase the integer that says how many likes this video has, and I'll see you all next time. Bye.